Alright, today's lesson is going to be on finding the domain of functions and a little bit of finding when two functions are equal. So this is going to be lesson 1.4c, and we'll just call it domain since that's the biggest idea of today, is finding the domain. Alright, so for example 1, we're going to find the values for which f of x equals g of x. Alright, and our first one for a, f of x is 2x squared, and g of x is x squared minus 5x. So if we want to find where these two are equal, we are going to set them equal to each other. So I just take 2x squared, set it equal to x squared minus 5x. Now this is a quadratic equation, and it's also a quadratic equation that has x squared and it has x. So most of the time we're going to try to solve these type by factoring. So to factor, we want to get everything on one side. So I am just going to move everything to the left. So I'm going to subtract x squared from 2x squared. And then I'm going to move the 5x over, so it's negative on the right. It should be positive on the left. Okay, so this has two terms, so it's a binomial. And so we're going to factor it. The two ways we've learned to factor binomials so far is factoring out a common factor and the difference of squares. So these are obviously not squares. So we're going to factor out a common factor, which is x. And that's going to leave us with two values of x that will make those two functions equal. 0 and negative 5. Alright, so let's do another one of those. So for b, we want to find when f of x equals g of x. F of x is x to the fourth plus 1, and g of x is negative 5x squared plus 15. Alright, so we are going to set those equal. So x to the fourth plus 1 equals negative 5x squared plus 15. Okay, again, well, this isn't a quadratic equation, it's a quartic, but we're going to kind of use our quadratic rules for it. So we're going to get everything on one side again. It says everything. It looks, I don't know what it looks like it says. But I'm going to move the 5x squared over, and I'm going to put it in the middle. So we're in descending order. And then I'll subtract 15 from 1 and get negative 14. Now this is a quartic equation, but we're going to use quadratic rules. So it's a trinomial. There's three terms. So we'll do our two sets of parentheses, just like a regular old trinomial. All right, and then what we put here and here are going to need to multiply to give us x to the fourth. All right, so that is going to be x squared and x squared. It's really the only thing different about factoring it than a regular quadratic. Everything else is going to be the same. So because this is a minus, I know in my factors, my signs are different. So one's a plus and one's a minus. And then what I put here and here is going to need to multiply to give me that 14. So I could do 1 and 14 or 2 and 7. And then when I multiply these, they're going to need to add to give me 5x squared. All right, so if I was just guessing, I would probably guess the 2 and the 7 instead of the 1 and 14. And if I put the 7 here and the 2 here, when I multiply that outside, I'm going to get negative 2x squared. When I multiply that inside, I'm going to get 7x squared, and those do combine to give me your 5x squared. All right, so now I'm going to set each one of those equal to 0. And then solve it for x. So I'm going to subtract 7 and then do the square root. Don't forget the positive and negative square root. Now, eventually soon, we are going to talk about imaginary solutions, but so far this year, we haven't introduced imaginary solutions. So there is not a real number that we can square and get a negative. So what we would say is that this is a non-real solution, and we're not finding that yet. So give us some time and we'll talk about what you do, and you may remember, but for now we're just going to say non-real. All right, on this one I'm going to add that 2 and then do the positive and negative square root. And so we get positive and negative square root of 2. All right, so the rest of the lesson is on finding what's called the implied domain. So like when you first learned about Algebra 1, you probably just learned it's the x values or it is the input values. And then as we get more and more advanced, there's an infinite number of those. And so we can't list them all. So what we do is we represent all the x values for which the function is defined. That's the implied domain. So what you guys need to think about is what makes a function undefined. And it might seem like there's a whole lot of those answers, but there are only 2 things that make a function undefined. So 2 things that are like illegal to do. One of those things is dividing by 0. And we talked about that a little bit when we were doing the rational equations. And the other thing for now, like domain, we're only talking about real numbers. So something that's going to make a number be unreal or imaginary, that is making a function undefined also. So it's going to be an even root of a negative. So even roots are like square roots, fourth roots, sixth roots. So any root where the index is an even number, the type of root is even. So that's it. So if you don't have a way that it's possible that you would ever have to divide by 0 or take an even root of a negative, then your domain doesn't have any restrictions. And we'll talk about some of those too. All right, so what I want you guys to do is make a table. So you might flip over on the back. I don't know where you are on your paper, but mine took up almost the whole back of a piece of paper. So we're going to start off with 4 columns. So one column, and you can start over in the margin if you need to, is label it what you have. All right, and then you're going to go down pretty low I may have to extend that in a minute. All right, the next column is going to say what you do. All right, and then this should be kind of in the middle of your paper since there's 4 columns. All right, the next one is going to be example. All right, and the last one is going to be the domain in words. So the challenge exam, like I've told you several times, I think, is multiple choice. And it's possible that the choice may be the domain in words, and so you'll have to be able to represent it that way as well. Okay, so one thing that you could have where you're going to have to restrict the domain is a variable, typically x, but it doesn't have to be, in the denominator. All right. So don't put the horizontal line yet. We're going to do some stuff first. So if you have a variable in the denominator, what you're going to do is set the denominator not equal to 0, because your denominator cannot be 0. So you're going to say whatever is down there is not equal to 0 and solve. All right, so let's look at an example. So for our example, we have f of x equals 2x plus 5 over x minus 4. So when you look at this and you see, okay, I have a variable in the denominator. This one I have to restrict the domain. So what I know is, for the domain, everything that's in that denominator cannot be 0. So that means that x cannot be 4. That's your domain. All right, and then if you wanted to represent that with interval notation, you would start off as far as you could to the left. So the smallest to the left is going to be negative infinity. Go to 4, but use a parenthesis that says you're not including 4. Do the u, do another parenthesis, and then you pick back up on the other side of 4 and go to infinity. So that's a pretty advanced interval notation, so it might take a little while for you to figure that out. I'm okay right now if you just say x does not equal 4. All right, and then for words, you're going to say, and I want them to be words, not symbols, so all real numbers except 4. Okay, so that's what you do when you have a variable in the denominator. All right, so let me draw my line. All right, and then we'll pick back up with something else. So the other thing you could have is a variable under an even root. All right. Now what you do when that's what you have, the radicand is what's underneath the radical, under the square root or under the fourth root. So you're going to set the radicand, whatever is under the root, greater than or equal to 0 and solve. All right, so let's look at an example. We want to find the domain of g of x equals the fourth root. I drew that a little bit too long. The fourth root of x plus 5 minus 7. So the minus 7 is not under the root. So we're doing this problem, we look, we see we have an even root. And so we take everything that's under the even root and we write that it's greater than or equal to 0. And then we solve it for x. So to solve this for x, we're just going to subtract the 5. And that's your domain. All the x's greater than or equal to 5. Now in interval notation, because it has the or equal to, it includes negative 5. So you would do a bracket, negative 5 to infinity. All right, and then in words, this is going to be all real numbers greater than or equal to negative 5. Okay, and I'm going to have to extend my table down because we have one more thing. Whoops. I love how that makes such straight lines. Okay, so now the last thing that we could have is no denominator and no even roots. So when that happens, it's awesome because there are no restrictions on your domain. So an example of a function with no even root and no denominator is h of x equals x squared plus 3x minus 5. No denominator, no even root. So for your domain, you would say all real numbers. Now I don't want you to put ARN, that drives me crazy. We're going to, for all real numbers, we're either going to do this fancy R, it's like a double scripted R, or in interval notation, all real numbers means from negative infinity to infinity. And then in words, it's just all real numbers. And that's it. There's your table. So as you're doing these problems, if you get confused, you can just go back to this table, look at what you have, and then go through and it tells you exactly what to do. All right, I'm going to do one more example that's not covered in the table because it's kind of like a double issue. So for example 2, we're going to find the domain. And f of x equals a fraction. The numerator is x minus 5. The denominator is the square root of x minus 2. Now I'm going to go ahead and tell you that they really like to put these on the ACT. So don't be surprised if you see an ACT question like this. So we have two things. We have a variable in the denominator and we have an even root that also happens to be in the denominator. So let's just talk about the first one. So we have a variable in the denominator, so we're going to set this whole denominator not equal to 0. So to solve that, we're going to square both sides to get rid of the square root. 0 squared is 0. So what we know for 1 is that x cannot be equal to 2. The other thing we have is a variable under an even root. So I know that radicand must be greater than or equal to 0. So x has to be greater than or equal to 2. So what we have to do is find a way to combine those for your domain. So x can't be 2, and x needs to be greater than or equal to 2. So think about how you can combine those. You just knock off the or equal to. Since x can't be 2, we would just say that x is greater than 2. And then for interval notation, you would use a parenthesis on it. That's your domain. That's the combination of not equaling to and greater than or equal to 2. All right. So let me get your assignment.